Welcome to the electronicshobbyblog.com. I'm your host, Dominic Soldano, and today we're going to finish our photo LED light. I've got all the parts to finish our photo LED light. I bought this case on Amazon. I didn't realize it was such a good quality case. It actually comes with a gasket seal. It would be a waterproof case, but I thought it would be cool to use the back half of it, which is clear, so that when we mount our photo LED light, some of the light will shine through the back and we'll be able to see all the hard work that we put into the LED photo light. So I've gone ahead and drilled holes for some 1/4-20 nuts. And these are some nuts I found on Amazon. I got a bag of 30 for around $7. You can see they're kind of recessed and they go in and they fit in a hole, and I put some epoxy around them just to make sure they stay in place. And I also found these little adjustable ball joints on Amazon, and they'll fit either a camera hot shoe, or you can take this off and they'll fit a light stand. And I installed 2 of these 1/4-20 nuts, and these will align with those 1/4-20 nuts. So you can either mount your lamp this way, or if you mount it here, you can mount it standing up. I also picked up on Amazon a couple of 10K potentiometers. I think I got 5 for about $7, and they came with these knobs. So all told, if we consider the parts that I bought off Amazon, I probably spent about $30 total on Amazon between the LEDs, the case, the ball joint, and the potentiometers. And if you consider how many items came in each and kind of figure out the price per item, I'd say the total cost of this project is going to come in at $25. Let's finish putting it together and then take a look at how it turned out. I had one last LED to add in. This was actually the LED that was left over when I created my groups of 3 and 4. It's one of the warm white ones, and so I've got to hook it up to the positive terminal for the warm white, which is the ones connected with the orange wires, and then the other side will get connected to the yellow wires. So I'm trying to keep the color scheme consistent so I always know what's going on. These are actually out of my breadboard wire kit. I have more that I can go to. And what we're going to do today is we're going to get these MOSFETs hooked up. We're not going to get the whole control circuit done because I'm still trying to decide what to do for the control circuit. I'm torn between simply using the 2 potentiometers and using a microcontroller that would control each color independently. Of course, I can do that with the 2 potentiometers as well. Now we can install our MOSFETs. So the way these work, hopefully this is showing up in focus, it's gate, drain, source. So this side goes directly to power, and this side goes to ground, and this is where the center pin is where each of the LED arrays connect, one on each of the MOSFETs. Depending on which way I go, I may put a second board in the bottom, and if I do that, bend these down, it's a nice big case. If I do put a second board in the bottom, with the microcontroller, that'll work. But I also want to make sure that if I don't, that there's room for the 2 potentiometers. These MOSFETs are not really going to get hot at all. They're carrying almost no current compared to what they're designed for. So I'm going to get one lead soldered, at least enough to hold it in place. Make sure it's nice and flat. You know, putting it flat against the board also acts as a heat sink. So the board itself is capable of sinking some heat. Not a lot, but more than none. And a little solder at the tab to the board in a couple of spots will not only hold it in place, just got to make sure we don't short anything, but also help to heat sink it. It's just tough to get the tab hot enough to take the solder, because it is in itself a fairly large heat sink. That should do it. So that'll provide a little extra heat sinking should we need it. Now MOSFET number 2. So now each of these needs to go to ground. Okay, so the outside of the barrel jack, or the negative lead, is this pin here, not this one. I am going to solder this one to the board for a good mechanical connection. It's also plus. And we want to connect. I always like to use a black wire for ground. Sorry guys, I know this is going in and out of focus. Just pushing it all the way on, make sure it's on there. I try to do as much of this as I can before I get it on to solder it. At least this being stripping and shaping. So this will be the grounds connected. There we go. Our MOSFETs now have a path to ground. Now let's connect the matrices. So power for the cool white matrix is the white wires, and the ground, which is what we're going to sync through the MOSFET, is the green wire. So we have to go from the green to one of the drains. And then power for the warm whites is my orange wires. And the yellow is the ground, which we're going to sync to the other drain. So I've got green wire and yellow wire so that we keep that consistent here to here. How's that? It's a short trip indeed. Basically need something the size of a staple. Perfect. There. There we go. Gonna snip those two. I'll leave the other one alone for now. And that was the warm white matrix, which is now controlled by this MOSFET. And now we're going to have the cool white matrix controlled by this MOSFET. Okay, I've got those installed and wired. We're going to assemble the potentiometers, the two potentiometers for our circuit. And I've got the soldering iron heated up, some heat shrink tubing, the first set of resistors that we're going to need, the two potentiometers, and I've pre-cut some wires to about 8 inches and strip them, and I'm going to tin them. And I've got a black and a red for each potentiometer. So black and a red for each potentiometer, and then a yellow, which will relate to the yellow colored ground. And I've got a white. I didn't have green, so the white will relate to the green colored ground. So the yellow will be the warm LEDs, and the white will be the cool white LEDs. So I am going to start by tinning these wires. And I'm just going to find something to rest them on to hold them off the surface. And I'm going to do all the wires at once just to get them out of the way and have them all tinned up. But I'm assuming you've also seen me tin wires before. So I'm going to finish this and I'll be back. So this is going to be the top of the potentiometer. And so that's where we want our 470K resistor. So I want to make sure this heat shrink, yep, will fit over. So what we want to do, I'm going to trim this down and create a loop. And that's going to fit onto the pin. So I'm going to tin the resistor. Okay. Tin the pin. And I'm going to bring the two together. So the next thing I'm going to do is I'm going to create a small loop on this end. And I'm also going to loop the red wire that I've tinned. And then I'll bring these two loops together and squish them, so I get a good mechanical connection. I'm hoping this isn't blurry, but I'm worried that it may be. Now I've got these two resistors, because this particular one is going to be for the warm white, and the warm white needed 16K. And there's no 16K resistor, so I've got a 15K and a 1K. And the way I'm going to do it is I'm just going to put them in series, right? Ohm's law. Resistors in series add. That's actually not Ohm's law, but it's an important thing to know for Ohm's law. There. And now I'll do the same thing I did with the other resistor. I'm leaving a little more loop space this time. I'll put that on a pin. Going to make a loop in the black wire, and that will match up to the loop in the resistor. Go. Final one I need to add is the yellow one. And again, I'm going to make a loop. And use the loop to make it easy to solder onto the pen. Okay. The final thing I want to do, just to make this look neat, is to cut some lengths of heat shrink. Prevent any shorts if things get knocked around. Run those up. It's too much. No sense in wasting that much heat shrink. Patch off. And I could probably get away without doing this, but it'll look more professional. And I use the barrel of my soldering iron to heat my heat shrink. If you buy good quality heat shrink, you can do that. I've seen people do it with a lighter too. I'm not too up on that method. I just don't think it's safe. You can burn something. The reason I don't use the tip of the iron, I use the barrel, is because I don't want solder all over my heat shrink. The small one I cut off I can use on the center post. One more piece on this side. About that long. Then this is ready to be soldered to the board. There's one assembly, ready to go in. Actually, I'll wire it to the board first. And then when I install it, I can screw the board in. So now I'm ready for the next one. So the next one's going to be exactly like the first one. There's still 120K at the top end of the resistor, but it's 17.2K at the bottom. So what I want to do is I want to make sure that this 120K resistor goes on the same side on both potentiometers so that both work in the same direction. Otherwise, with turning one direction will make it go up, and turning one the other direction will make it go down, or values won't be correct. So the side that gets the red wire gets the 120K resistor. And when the potentiometer is standing straight up, that's the left side for me. And on this end, I'm going to do exactly what I did earlier. I'm going to put the two resistors in series first. 15K and a 2.2K, which will add up to 17.2K. So I'm going to go ahead and finish wiring this, and then we'll come back when we're ready to solder them to the board. Okay, so with those done, the next step is to attach them to the back of the board. And the two reds are going to go together because that's our 12-volt in. So I'm going to simply wire those up. Now I could probably have cut some of these wires down, but it'd be nice to be able to lift the board off if there's a problem and just coil these up in the back. That won't cause a problem. And these can go anywhere there's power, which is anywhere there are orange wires. So the orange and the red go pretty much to the same place. I don't want to attach here though, because that's at the end of the diodes, lower voltage. So we want to come back here. So these could easily fit in right here. So I'm going to tin them first. Solder. And the two black wires go to the same place, and that is to ground. So I'm going to twist those together. And then I'm going to tin those. Good. And those can go anywhere there's ground. There we go. And finally, the yellow and the white, and the yellow will go to this pin of this MOSFET. Because that is the MOSFET that is controlling the warm white LEDs. And this white one, make sure it's neat, I don't want to mess, will go to the other pin, same pin in terms of position on the transistor, but on the other MOSFET. We are ready for a test. We've already plugged in our 12-volt power supply, and this is the jack. It's the warm white. The reason this LED is coming up early is because it's a single with a resistor. When the math worked out that there was one left over, not in a string of 3. And it looks like I've got one that's not working. It's on and it's very dim for some reason. I think it's probably a bad LED. There. All right, time for a retest. Okay, there's a fully working array. There's a fully working array. It's bright. Bright, bright, bright. Good, it's what it's supposed to be. Okay, so I'm going to get it in the case that I showed you earlier. And then we'll chalk it up, put the buttons on, chalk it up to done. All right, so let's take a look at the finished product. Here it is. This can either go on a cold shoe, on a camera, or just on, take that out, it'll mount on a light stand. It's adjustable, it's on a ball joint, warm weight, cool weight, and they're both independently adjustable. So you can use that to change the color temperature of the light. And I don't know if you can see this, but it's pretty bright. It's pretty bright back there. It's got a good reach to it. So as a key light, this would be great, or a little bit of a video light for getting in close. And you can see, I like that, the fact that we use the plastic case so we can see our hard work. And it's also pretty cool. You can see the light coming through. So I like that. What would I do differently? Well, I think as far as a prototype goes, I don't think there's a lot I would do differently. I think if I were building a prototype, I'd probably build the prototype exactly the same. I might mount the MOSFETs on the other side of the board, maybe keep things a little bit more away from the edges of the board, but I think that's probably it. If I were going into production or going to make another one, this was a lot of soldering. I mean, a lot of soldering to do 177 LEDs plus the control circuitry. So I would probably, if I were going to change it, I would probably order up a circuit board. I would go on to either Altium Circuit Designer or use EagleCAD and design a circuit board and have it made. You'd probably have these made, probably get 10 of them for about $100. That would have made life a lot easier. But all in all, it was a really fun project. I hope you'll build one, because I know I really enjoyed building it, and I've actually got something now that I can use. I do wish it was battery powered, but that would have added quite a bit to the expense to put the battery holder on it or try to find a battery holder. I probably would have had to break down something else to get a battery holder for it, for a battery that would push out that much current. Anyway, hope you like that. Hope you'll build your own. If you found this useful, then hit that like button, hit that subscribe button, and until next time, cheers.